All right, let's get started. Thank you for inviting me, and thank you guys for coming over. Developer experience is like amazing thing. I've been working majority of my career on building great tools for engineers. So developer experience is fantastic. This is my passion. For me, this is the same thing as developer productivity or happiness or even scaling engineering. For me, those are same things. And I want to tell you how we do things at LinkedIn. So developer experience or productivity, what is the goal? At least how we see that goal at LinkedIn. So we want all the engineering force to be able to write high quality products like every day consistently. And how we do it at LinkedIn, we have like 300 people working on tools for engineers. So that's a lot of people. Like with 300 people, we should be unstoppable. We should just, build so many great tools. In reality, we have many tools, but we are still not there. Like we have appetite to like improve that experience, do amazing things. Leverage the distributed refactoring plugin that Netflix is developing, for sure. So yeah, but in our mission is not only tools. So for developer experience and productivity, we also believe in our team that it's the practices and the methodology is also important. So we want to make sure that the tools reinforce the correct behaviors. The tools make it easy for engineers to do the right thing, right? The whole tooling, building the tooling experience and tools for engineers at LinkedIn, I guess it really started about 5 years ago, where LinkedIn, technology-wise, was not in great shape. There was some tech debt. It was hurting business. We couldn't get the releases quick enough. We couldn't get building features was essentially expensive. So that led to a project called Inversion. Let's build the tooling that we need to get really the developer productivity up to the level that we require. And at that time, like bunch of tools were developed that we still maintain and improve and develop more. But that was the starting point. One of the fundamental decisions made at that time is we don't want to do monorepo again. So we had a bad experience with monorepo. And this is like, I could repeat what John was saying, so let's just move on. In general, a lot of tools that we provide for engineers for them to be productive and have a great experience is essentially like making this multi-repo working. Yeah? And it's so nicely ties with John's talk. We have a name for that API at LinkedIn. It's called Multiproduct. And it's essentially a layer of tools on top of like building and like various technology stacks that provides that like engineering experience. So let me zoom into that. So it starts with a creation of multiproduct. And multiproduct, think about it as a single repository, right? Like typically a team has multiple repos, multiple multi-products that they maintain. So like think about multi-product as you come to the office in Monday morning, you create a new multi-product, let's say it's a service of some sort, and like within minutes you can get it receiving the real traffic from production the same day. So the entire like workflow is sorted out because you've created this multi-product in like using our tools. So like you've got continuous integration with that on like essentially entire workflow that you need to engineer that product to be like some great product that users will use. So multi-product is also creation. Another thing that is important with the multi-product API is the enterprise dependency graph. So essentially understanding all the dependencies between those multi-products, between those separate multi-repos. And this is pretty amazing thing. Not like everybody has that. I remember back in the days, and probably these days many organizations don't know exactly, what are the dependencies between projects, right? Those discrete teams, they know, okay, we are using that component, so we understand that dependency, but they don't see the full picture. And owning that graph gives a lot of gives potential to build great tools on top of that, and I'll zoom into that later. Another thing that we achieved with multi-product is that we have a consistent layer on top of any technology stack. So essentially, regardless what sort of application or service you're building, whether it's an Android app or iOS or C++ library or Java or something else, you will create a multi-product. So you'll have a consistent experience. And also, this allows us to build tools, the whole ecosystem of tools that work with multi-product API. So we don't have to build tools that work with every single particular technology stack. We can build tools that work with this multi-product API. So hopefully it makes sense. While I go, I hope it's all going to be clear. So this multi-product idea is pretty successful at LinkedIn. We have about 4,500 multi-products right now, and it's going to be way more than 6,000 next year, I think. So that's a very low estimate. So it's getting there. And now what I want to do is I want to zoom into a software change lifecycle in that multi-product. So how does it go from commit to production when you're working on a multi-product? And I'll stick to the high level. There's going to be a lot of Q&A, I think, afterwards. So I stay at high level. So no code on the screen. The first thing is pre-commit code review. So this is mandatory for every team. You create a multi-product. You have code review tools associated with that. And every time you make a change, it needs to be reviewed by somebody else on your team before you can actually push that change. I'm using the term pre-commit, but you probably all use Git, so it's more like a pre-push. So before you push code, you have to get a code review. And for that, we use the review board tool that has a bunch of plugins that we needed to implement so that it works better at LinkedIn scale and satisfies more LinkedIn requirements. And there are ways to bypass that if you need to, but in general, every code change needs to be reviewed. And this is actually pretty cool at LinkedIn. I love code. No, actually no. The pair programming is the best experience for reviewing code and learning and building highest quality products. And then there's long time nothing and then code reviews. But then it really works at LinkedIn, those code reviews. So it really helps transferring knowledge. The culture of feedback is really good. People are happy to receive critical feedback. Let's change this. Here are the suggestions. So this is pretty cool. Not every code review has the same high quality. Sometimes code reviews are style stuff, not that interesting. But in general, code reviews are working very well. So what happens next? What's the next phase? It's the standard a commit validation that you know from continuous integration servers. One of the things at LinkedIn is that teams, in using their multi-product API, they can declare what happens in the postcommit, after they push code, and what happens before they push code. So you can put more validation pre-push, and some of the teams are actually doing that. I'll get to that later. They actually put all kinds of validation, entire validation before code gets merged to the master branch. This gives them this nice feature that the master branch, the main development branch, is nearly always is healthy. It never has build failure. And I'll get to that use case later. But let's say by default in the normal Java library, I would say that typically teams in the pre-commit, they have style checks and things like that. And post-commit, they have more time-consuming tests, integration tests and stuff. And this is all configurable. But the next thing is really important and very interesting at LinkedIn. So it's the automated validation of dependers. And we are now leveraging this dependency graph because we know what are the dependencies between those multi-products, between those multi-repos. We know that, let's say you made the change into that Java library, but there are 10 other libraries that depend on your code. So we can rebuild them with your changes to make sure that your change does not break them. And this is how we can enforce semantic versioning. This is how we can help teams understand that, you're breaking some of the clients, don't push that change out. We do it automatically. When you push your code change, it goes through the pipeline, and there is this step of automated validation of dependers. But we also allow engineers to validate the dependers from your local environment. So you have some dirty changes. You don't want to commit anything. You don't want to generate a code review. You just want to test that out. How does this change play with your dependers? So there's one invocation. What happens is a diff of your changes that you have in your workspace gets sent to our cloud of that runs all the builds, and we rebuild all the dependers with your change, and you get signal. Whether after, I don't know how it takes, depending how many dependers you have. And I'm unfortunate to, my team is sort of unfortunate and fortunate to own some of the infrastructural dependencies that have thousands of dependents, and the signal is always like failure or something. Because there's always some flakiness in one of the projects that you'll have to take a look at. So the more dependers you have, the harder it is to get really clear signal, whether your change is like really like safe, but it's it's a trade-off. I mentioned semantic versioning. What we are pushing and what our tools are pushing the teams is to embrace semantic versioning and not introduce breaking changes like unintentionally, like no regressions. We want to detect them. We want to also, however, if like from time to time, every software project, in order to be healthy, needs to get a new major version out. So yeah, we need to change the API. Like these API worked very well for the past few years, but now we understand that there are more use cases. We have to change that, right? So you consciously change the API in a breaking way, so the team rolls out new major version, and that works in our tools. We basically ignore the result. We know that you are pushing out new major version. We are not going to stop that publication if one of your dependers fail, because you have you're rolling out a new major version. The next step, let's assume that the validation of dependers was successful. The next step is a new version is created for whatever library you were working on, code you were working on. And this is very important because I remember that way in the past, and maybe like many companies are doing it still this way, where like usually the team works and make changes to the code repository. They make changes, and at some point in time, they decide, oh, it's time to release, right? And usually a new version is created that really like captures a bunch of changes, right? A set of changes. So this is not how we do it at LinkedIn. At LinkedIn, every code change will create a new version. Now, like it does not mean that you necessarily have to push that new version to your clients or something like that. But like it's important to understand that this is where we where we push our teams to. Like we really want them to be also embracing continuous delivery. So like every commit can be actually a release candidate. So this is like a continuous delivery nirvana, that every commit is so high quality that it can be really rolled out to the client, possibly. And that fuels the next step of the life cycle, which is we need to also help with life cycle of that version. So the version is created, it sits in our binary repository, but like that's not enough, right? You can work, like someone can work on, he can create beautiful tests and fantastic code, and he can like roll out that change that passes all the builds and it's beautiful and there's new version Artifactory or somewhere else, but it's essentially wasted effort until somebody uses that version, right? So we want to help with the tools for engineers to like start rolling those changes out and then getting those versions used. Otherwise, it's really wasted effort. Change that is not used by anyone. So what do we have for that? So for example, we have tools that allow you to roll out a version to your consumers, just like push out the version so you decide which version and what consumers you want to affect. You can choose all of them and just roll it out. And it's working, but it's, sometimes there is this bad sentiment that someone is, changing my project, is pushing me versions. So there's an interesting energy there. You can also manage the lifecycle of the version and decide that I'm going to deprecate this set of versions. This will be the end of life date, and the deprecation will cause certain signals to the team that is using deprecated code that they should change, update to a new version. And at some point, that version will expire and they'll have build failures. So they will have to fix the problem, even if they have ignored deprecations. And sometimes it happens that teams keep ignoring that until there's EOL and then there's a problem. But and sometimes it happens that we just move EOL date further. So it really depends. Another thing we have is wildcard versions or dynamic versions. And I guess this is something you can achieve with Gradle, with those plus, with various kinds of ways of declaring dependencies, where you actually, with every build, like the build can check, and if there's a new version available, you grab it. So we also have that at the multi-product level, which means that we have this wildcard dynamic resolution, not only for like typical Java Gradle builds, but all kinds of like technology that is adapted to multi-product at LinkedIn. All right. So I want to move back from libraries. So I talked with libraries. So with libraries, like, okay, so at LinkedIn we have this distinction. Some of the projects and some of the multi-products are libraries, and some of the projects are, we call them deployables, or like applications. And like usually libraries are not user-facing ever. Like the deployables, the applications are user-facing. So for those kinds of multi-products, the steps, the lifecycle is different. It's more complicated. It's more interesting. There is more tools that are available. So previously I mentioned about libraries. When you get a new library version and it's consumed by clients, by other like projects at LinkedIn, you're essentially done. Like you can move on. You can work on another more changes. With applications, it's a little bit different. So let's talk about like how we do Canary releases. So essentially, let's say your application runs on 100 instances. So given that your code changed to that application, moved through the pipeline, and it passed all the validations, you can actually go to the tool that we have, and you can nominate that version that was created internally to go as a Canary, to be released as a Canary. So of those 100 instances that serve the production traffic, and that's your application, one instance will get the new version, and there's going to be a bunch of monitoring on top of that instance to make sure that like things are in order, that the Canary is healthy. So typically, I don't remember exactly, but the Canaries I think expire after like 2 or 3 hours. So usually like an engineer decides to roll out a Canary. He checks out whether the signals are good, and the signals are various, like some basic things like CPU and memory to like some unique exceptions that we see, or for example, or there are also custom signals that the teams can like implement to validate the healthiness of the Canary version. Once the engineer is like happy, he can roll out to like other instances, and essentially like the new version of the app is released to all the instances. And next phase is ramping up features, because the way we develop features at LinkedIn is they are always hidden behind this layer of like A/B testing. We call it LIX at LinkedIn experimental framework, I think. And essentially, this is our safety net. A/B testing comes from like I know that a bunch of people at Netflix like use it like big time. So how many of you are from Netflix actually? Like half of them. So the way I conceptually think about A/B testing is feature branching in code, and like it was used in the past like to like experiment. Let's make this feature visible only to 1% of our customers, just in case it's not really working very well. Let's experiment, and then let's collect signals, and if the feedback is good, let's get this feature rolled out. So at LinkedIn, we use this A/B testing layer to essentially ensure that every single feature that is rolled out is really, it can be like safely rolled back, and we can slowly ramp up any kinds of features. And that's essentially like every feature that gets to those that gets out to those applications is like behind this layer. What else I have? I think so that will be the like I guess this is simplified because there are like so many tools there, and I don't have that much time. We can like zoom into one of them and sort of deep dive. But that will be like at the high level the software change lifecycle, the way at least I see it at LinkedIn. There is this fork here that the applications have slightly different steps here, and then applications and libraries. There's a distinction there. But I want to move on to the one very interesting subject, which is continuous delivery and 3x3. This is something that we had to embrace last year when we created the new mobile experience, the new mobile apps. there was a very hard requirement for the new app that we were developing, that like it has to be 3 by 3. It means the maximum time from commit to production is 3 hours, and there are 3 releases to production per day. And you can imagine that this requirement puts like enormous pressure on the team to get the automation right? Like you gotta have great like tests that will ensure high quality. Like there's no way you can fit any manual testing there. Like everything needs to be automated. There can be no flakiness, and like everything needs to really work. This is like a big app, like really many, like dozens of engineers work, even more than 100 engineers working on those all apps. So like it's like a big scale. And one of the interesting things they've discovered very quickly, like flaky test is worse than no test. Like, and that was always my opinion. Like in order to implement continuous delivery, you have to address the flaky tests, right? Because to get continuous delivery, you've got to write so many tests, and that's at various levels to get the good quality signal, that the flakiness will be there. Like the flakiness from tools that are not from simulators, from like a technology that you're using. Like there are so many like challenges with flaky tests when you start really like building big apps for mobile world. The team that was like building the infrastructure, they came up with this term like no flakiness. We've got to like nail down this flakiness. Actually, I have a question to you. So 99.9% stable is pretty good, right? As a test. Yeah, most of the time it works. What if you have 1,000 tests and each of them is like that stable? Guess what's the like overall stability of the suite? No calculator, just guess. Around 40? 20. Not too bad. I think around 30 or 40%. So like that's unacceptable. Like it has to be super stable in order to get this continuous delivery, and it really, yeah. So what they've implemented, and we are now scaling that to other teams, is essentially automated flaky test detection. The way it works, they discovered that after business hours, Pacific time, there's not much going on in our farm of continuous integration servers. We can run some builds. So they run the same builds all over again for all the projects involved. And if you run 1,000 times a build or a test, you'll find out whether it's flaky or not, right? Without any code changes, just run it again and again and again. So that's how we are detecting those tests. And there is a process. When the test is detected, it's removed from the suite, it's disabled, there's a Jira ticket created, there's someone watching and tracking when it's fixed. So this whole like workflow after that. There's a bunch of investments into making those builds fast and the tests also fast. The team had to change various like open source tools for like, especially in the mobile world, to get those tests really fast. We did very heavy parallelization. So for example, we've added to the Multiproduct API, we've added a feature that you can run some of your tests on the distributed machines. This is essentially you configure your projects that this part will run separately on some distributed machine to squeeze as much speed as we can from those builds to get to that 3 by 3, 3 hours, 3 hours maximum time commit to production, and 3 releases per day. Finally, last slide, I promise. Finally, we had to make the master branch always healthy. Like if you have a lot of engineers, and like in small teams, when the build is broken for a few hours, it's not it's not a biggie. But in a big team that aspires for continuous delivery for like 3 by 3, as we coined it, we've got to have master branch always healthy. So basically, in that team, all the testing, everything happens like in the pre-push. Like after push, it also happens, just in case. But it has consequences. So for example, it takes longer for your commit to actually end in the actually get delivered to the main development branch. The tools that we developed to make that possible was like Git queue mechanism. So like you actually send, instead of like pushing, you actually send your commits over, and when it gets on the queue, when the tests are happy, that change gets into the master branch. And It's 8. I think we wanted to have like a mingling session after that until 9. But I, know, I guess I can take a few questions. Yeah?
So,
all right, questions then.
So when you said you test dependers,
Yes.
Is that only binary dependencies, or does that also include API dependencies?
We don't. Okay, it's a good question. Like the tests of dependers, whether it's testing like API dependencies or binary dependencies. So it's pretty unsmart. It tests dependency. We don't like our dependency. The graph does not understand API or binary dependency. It's just dependency. We would love to have that, because this way we could like avoid unnecessary like builds, right? Unnecessary tests, and potentially avoid unnecessary like debugging if one of those unnecessary builds actually fails and you have to find out why. So good question. In current form, no, we don't really differentiate. John?
Are you building just first order dependers or also transitive dependers as
Great
well?
question. Depender testing is only first level dependencies. And that's by design. To be honest, I would like to build like everything, because that would be cool. That would be a really good signal. But like it wouldn't scale very well, I think, at least at LinkedIn. And also the way we think about it is like semantic versioning is important, that like you should not break your dependers. So that's how like we think about it. And for now, we are satisfied with first level. And actually, we don't really have a lot of like feedback from engineers at LinkedIn that they need this sort of recursive rebuilding. So that's a good indicator. I haven't heard about that actually. I know that like somewhat like Google does it, right, with this monorepo stuff, right? Your question? Oh, Justin, go for it. I thought somebody here had a question.
For 2 parts. So when you say build dependence, I assume you're running their tests, right?
It's a good question. Essentially, so what happens during the build is configurable by the team, right? So like typically it's building the jar, like compiling, running tests, and building the binaries. Typically what happens, unless the team has configured something different there, like in the build instruction. But yeah, it's just essentially building that depender.
So I'd be curious to know what sort of LinkedIn engineers feel about how much confidence they get from those, what would be unit tests, maybe integration tests, but that would probably leave out, maybe a case would be like a smoke test. So we have a category of tests that we only really feel confident given the lack of our other tests, where we have to actually stand it up on an instance and run it there and test it there. And that's only the way we really feel confident. I mean, it's not ideal. I mean, I think we wish we had unit tests that gave us that confidence, but we don't. So we have an extra layer of sort of testing that we do. Would you think you have a gap, or do you think that the unit testing is completely sufficient and you're all good?
Yeah, it's a question. Yeah, it's a good question. That could depend on the team, whether how confident they are. We are pushing towards this model that we don't have any specialized like kinds of tests that like has to be run in somewhat semi-manual way. We are like going towards like fully automated model, like 3x3. So like I talked about like Canary releases and then ramping up features using this A/B testing layer. Like we also want to automate that. So like if all the signals are good, like everything gets rolled out. So like essentially we want engineers to be comfortable with that model. So they have to figure it out. They have to like build the automation to the level that they are confident. And there's a long way, right? That's one team that is there are several apps connected to that team that we built. It's all the like mobile experience. Last year, there are like other projects that do it, but it's not like let's say it's not like every single project at LinkedIn like leverages that and actually utilizes this style. I don't know if I answered your question. So like, there's always chance that I'm rambling how we do stuff at LinkedIn. Okay. Go ahead.
What if one of my dependencies breaks, but it's because they have flakiness? Am I blocked or?
Unfortunately, you are blocked, and this is something we need to get that fixed soon. So this is a great question. So when we validate the dependers, if they have any flakiness, that flakiness impacts you, your ability to like consistently like push in changes. This is very like annoying. You can imagine, and then. I live and breathe that annoyance because I've been like doing infrastructure stuff for LinkedIn like since maybe 2011. There was always we had 100,000 dependers. There's always one or few of them flaky. which gives us this bad signal. So we are working on improving the signals from this. We call it dependency testing, from this dependency testing. And then we will start with some like simple like heuristics, like if the percentage of your build successful and you are comfortable with having, let's say, 95% of the like success rate, then if you are confident, then we'll just publish automatically. But there's more interesting things we could do. Like we could, actually we have tools for that, to address that to some degree. For example, if we detect, it's not for flakiness, but if we detect that the project has rather consistent problems building, it gets out of this pool of dependers like testing. Because like, let's say a team has introduced something that breaks the build with every build. So that would, like, you know, the signal from dependency testing for everybody that they depend on would be that they always fail, right? So we already have some automation to like, to address that. But in general, like, we need to add more, way more, to get those signals from the dependency testing really like, you know, really good. So that, you know, when you see a failure, you know, oh, this is a failure, I broke somebody. But it's not, oh, it's a failure, but it's probably flakiness, I have to investigate it, and well, it's flakiness, I need to like rerun my build or like push my artifact or something like that. Yep.
When you guys have critical production issues, what's the process for getting a fix out?
So that, you know, it's like faster. So we bypass some of the checks. That's where you're. So you're asking, what do we do?
Give me an example, like if LinkedIn.com was just down, and you knew, and you've discovered what the issue is, but you have to push out code to do it. What's the process?
So there are ways to like bypass like all like this process can be bypassed if necessary for like really like severe like problems, but that happens very rarely. Like usually this leaks layer where we just, you know, ramp up features slowly helps. But like sometimes, yeah, we have like side outages, like rarely, but they happen. And it's kind of hard to say if there is a, like the process is much simpler. Sometimes you just like, you know, like there's a war room, like this, you know, we've got to like get this up as soon as possible, figure out what the problem is. So I guess when the site is down, like we got to get this like fixed as soon as possible. So like really like, I don't think there's like, I mean, there's a process, there are SREs, site reliability engineers, but like it's most important to get the experience back, to get the site back on. Oscar?
Just a comment on that. So the philosophy is you can bypass all of the process, but it has to be a conscious choice. So you don't want to be surprised by, oh, why did this suddenly happen, right? Like, why did this, you know, why did this get pushed without a code review? But if you took the choice of bypassing the code review, then that's fine. Just to...
Yeah. You had a question?
Yeah, similar to having a flaky depender, I could just have a slow depender build. So I
Yes.
went through to make my build 1 minute, and now somebody
Yes.
take an hour. That's going to suck. And
Yes.
you find yourself nagging your dependers a whole lot.
No. It's hard to say. I think it depends on the team, depends on the use case. I don't think, like people are not like asking about that feature often, but I've heard like feedback like that. It's like I gotta take this change out. So what people do is like we have some like ways of bypassing that. Like one of is like a magic, you know, incantation you put in the commit message that, you know, bypasses parts of that process and gets your publication faster. You will still get signal, but the signal will not block the publication. So as long as you build the binary, it gets out. So you have ways. We don't have it that often, that use case. Usually because every change produces a new version and it's sort of automated, right? Then there's not often a case where you're really like waiting for that. So even if it takes a couple of hours, especially if you have a lot of dependers, like in my case, in my team's case, it's fine. We can just wait those couple of hours. It doesn't really bother us. Yeah. All right.
Do you roll back, or is your philosophy rollback is for wimps and you always fix forward? And if you
That's
do
a good question.
roll
Rollback or
because you're doing the slow rollout, how does that work?
it will be. It would depend, I guess. If it's an application,
Right.
you know, rollback would be like because we regress the experience of the user, you know, so it's rollback. For like certain like library, if someone works on the library and know their consumers and stuff, they can just, you know, fix forward and it's okay. it kind of depends on like on position of that product
Right.
in the.
So if it's a service and you're doing a slow rollout, you might only find out, I don't know, once you're
Yes.
50% in or whatever. And so then how does that?
No, so that would be like it will be hard. It might be hard to roll back in that case because you have a stack of changes. You can't identify
Which servers have?
yeah, or like yeah, there were a couple of versions and stuff. Like maybe it was introduced in the past versions. So that would be like some patch release. That would be like a forward. That would be like a
Wait, maybe the old
yes.
version?
That would be this patch forward, I guess. In that case. Okay, you go.
For the Canary signal, is that automated and is it like automatically processed, or how is that a manual thing? How does that?
It's so it's automated, but most of the teams right now they make a conscious decision to roll out a Canary. So we are going there. We want to like get that automated. Majority of the teams to have that automated. This means that we have to make sure that the signals are really good, because if it's manual, then the signals can be relatively okay. You don't need to have them like super great. So so there is a whole tool that like show you all the signals and stuff, but most of the teams like make a conscious decision. And then there are teams that are leveraging the full automation, but that's also like with the Canary, like there's a you can't really do it like on the mobile experience, right? So like this, it's really different it's slightly different for mobile experience when we're talking about the native apps for mobile. And like I don't know like how much time we have. It's 8:22. Do you wanna run 5 more minutes?
Yeah, one more question or so. Yeah.
Okay, cool. So let's finish by 8:30 if you have questions.
Right. Was it always one Canary? Why not 2 or 3?
You know what? I asked actually that question recently, and they told me that usually it works. Like one Canary is just enough. It's just like it's easy and it really like gives enough signal. So we don't really have to have multiple
hardware
Canaries.
issue or just something strange like that happened to land on the Canary happened to land
So
on
like so this is not like my specialty because like, I'm doing the overview, but I'm really like my team is really on the build tools and the Gradle end and stuff. So I don't know exactly. As far as I know, there is a way of like using multiple instances for Canary, but what I was told is that this is usually not used. Like usually it's one instance, and that is sufficient.
I'm Szczepan's colleague from deployment tools.
Oh, cool.
So that is configurable. Like the default is one Canary, but you can configure it to be anything you want. And like some teams do several Canaries, not just one. Yeah. And the default is 6 hours now for expiration. But even that is configurable. You can say I need a week. Like some teams need a long time to validate.
Thank you.
Canaries.
Most of Netflix Canaries use multiple instances specifically for that problem.
I see.
It's very common to run into bad instances.
Okay.
And we have even one team that kind of does like a ramp up of Canary. So they have like 10 partitions where the Canary, they do a Canary on the first partition, and they promote the first partition, and then they do a Canary on the next one, etc., etc. So they do like a really gradual ramp up there.
There was one more question.
If you change affecting interface of your library for the clients, the code change, does it go to the owners of dependent libraries or the clients? Do other people see that you change the interface? Or how it's communicated between the teams?
Oh, this is a great question. So there are a few ways. If the team is leveraging wildcard versions, they'll just pick that up automatically next time they make a build. Otherwise, there is a way to like push your upgrade to the teams. So like you as the owner of that change of that library, you initiate that process. The third way is you deprecate and you end of life, so they'll have to migrate at some point. And there's one more tool that we have that is not used very often, I don't think. Yeah. So there's a way to, we call it like shepherd your migration. So it's more like a tool that helps you like prod the owners. Like, hey guys, you need but automates the steps you would do. It automates this process of going to those teams and hey, can you upgrade? Can you upgrade? So it's like putting some automation on top of that. So those are the ways we have. And other than that, you have like normal ways like communicating with teams, like emails and stuff. But it's like, it's like not all, like sometimes it doesn't work. Sometimes teams don't upgrade. So that's, that's a challenge to get it right in the organization. Oh, one more question.
Is your multi-product stuff publicly talked about? That seems very interesting, and there's a lot of polyglot implied there. I'm just curious how you make that magic work.
It's like multi-product. I don't think it's like very magic. It's essentially you drop a metadata file with every source repo that you have. In this metadata file, you like configure certain things. What happens, let's say, when you make a build, and also you have to like list your dependencies in that metadata file so that we can have a consistent way of declaring dependencies, not only like build or Gradle files, but something that is consistent for any technology stack. So those are like examples. And then our tools know how to like parse that metadata file and understand what your project is and what it's doing. So that's, I guess, all magic. And then, yeah. I can like talk more about that. This is like specialty of my team, but like I don't know how you want to get into that. Yep.
3,500 of these multi-products sounds like a lot to me. I mean, I'm not sure to realize exactly what it represents. Does it represent a bunch of microservices, for instance, plus some components of mobile apps and some...
I see. So, like, what does it represent? I guess it represents 3.5 thousand. Actually, it should be 4.5 thousand. Like, it's not right. 4.5 thousand source repos with all the like engineering tooling on top of that. And the source repo might be a source repo that if you go to LinkedIn.com, that's not the best example. On your mobile, if you go to LinkedIn.com, what you see there is a multi-product, like in our code, so something really big. Or it can be something as simple as like a little Java library that has 50 classes or something like that. So it really depends. It might be also a multi-product that is something that is dead, that somebody has created. Nobody ever used it, but it stays. So we have some mechanisms for garbage collection. Not very automated. They need to be automated. But like somebody works on training material, they create a multi-product because it gives them CI builds for free. So it really depends. From apps, libraries to like certain like side projects and stuff, like all kinds of stuff. All right, I think that's it. Thank you very much. Thank you for inviting me.